Welcome. In this module, we're going to dive into the core of AI, machine learning. At its heart, machine learning is a specific subset of AI that teaches a computer to learn from data rather than from explicit rules. Instead of writing endless code for every possibility, you simply provide a large amount of data. The computer then finds its own patterns and makes predictions. This is what allows systems like Netflix to suggest movies you might like or your email to filter spam. The amazing thing is that a machine learning model improves on its own as it gets more data, becoming smarter and more accurate over time. The machine learning process. Machine learning uses math to find patterns in data. You can think of a model as a function. It takes input values and gives an output value. The process of creating this function is called training. Once trained, you can use it to make predictions on new data, which is called inference. Training the model. Training data is the collection of past observations a machine learning model uses to learn. It's like a history book full of examples. In most cases, these observations include the features, the facts about something, and the label, the answer you want the model to learn. Features are the facts or attributes of the thing you're observing. They are the details the model uses to make its prediction. For example, if you're training a model to predict the price of a house, the features would be things like the number of bedrooms, the square footage, the age of the house, the location. Features are often referred to as X. The label is the correct answer. It's the value you want the model to predict. Using our house example, the label would be the actual, final sale price of each house in your dataset. The model learns by looking at all the features and seeing how they relate to the correct label. Once it learns this relationship, it can try to predict the label for a new house it has never seen before. Labels are often referred to as Y. Next is the algorithm. The algorithm's job is to figure out the relationship between the house features and the final price. It tries to find a general rule, a sort of hidden formula that can be used to predict the price of any house, even one it hasn't seen before. In mathematical notation, where the algorithm is a function, y equals f of x. The model gives you a prediction which is a calculated guess. In math, we show that as y hat to distinguish it from the true value. That's a glimpse behind the scenes. In the next module, we'll dive deeper into how to build a model. For now, let's explore the different types of machine learning. There are three main types of machine learning, and the type you choose depends on your data and the problem you're trying to solve. There's supervised learning, where a teacher guides the learning. Unsupervised learning, where the model finds patterns on its own, and reinforcement learning, where the model learns through trial and error. Supervised, unsupervised, and reinforcement learning are the three main types of machine learning, categorized by how a model learns from data. Supervised machine learning is the most common type of machine learning, and it's all about learning from a labeled dataset. A labeled dataset is one where all the data has the correct answers, also known as the ground truth. There are two main types: classification, which predicts categorical outputs, and regression, which predicts continuous numerical values. Let's look at the basics of how regression works. Think back to our house price example. A regression model uses the features of a house, like its size, number of bedrooms, and location, to predict a specific price. It's essentially drawing a line through all the past data to figure out the most likely price for a new house. Classification. Classification is a type of supervised machine learning where the model's output is a category or class. Instead of predicting a number like in regression, it places data into a specific group. Binary classification. Binary classification is a type of supervised learning where the model predicts one of two possible outcomes. In other words, the model determines whether an item is or isn't part of a specific group. Like a spam filter, a binary classification model looks at an email and makes a simple yes or no decision. Is it spam or not spam? The model can only give a single prediction from these two mutually exclusive options, making it a powerful tool for these types of true-false or positive-negative scenarios. Multiclass classification. Multiclass classification extends binary classification by predicting a label from more than two categories. The model is trained to choose a single, mutually exclusive label from a known set of options. For instance, a model might look at a photo of a pet and classify it as a cat, a dog, or a fish. While most multiclass classification models select a single label, some advanced scenarios use multilabel classification, where an item can be assigned more than one label. For example, a movie could be categorized as both a comedy and science fiction. Unsupervised learning. Unsupervised learning is a type of machine learning where the model works with an unlabeled dataset. This means the data doesn't come with any correct answers or ground truth. The model's job is to explore the data on its own and find hidden patterns, groupings, or structures. Think about a company trying to understand its customers. With an unlabeled dataset of customer information, an unsupervised model can find patterns on its own and group customers into different segments, for example, frequent shoppers or first-time buyers. The model discovers these categories without ever being told what to look for. Think of clustering as sorting a box of mixed items without any instructions. The model analyzes the characteristics of each item and puts them into piles based on what it finds. It learns these categories by itself. Reinforcement learning is a method where an AI agent learns to perform a task through trial and error within an environment. Unlike the other types of machine learning, it doesn't use a dataset. Instead, it learns by receiving rewards for good actions and penalties for bad ones, with the goal of maximizing its total reward over time. Reinforcement learning is often used for playing games like chess or Go, where the AI can experiment with different moves and learn which ones lead to a win. Controlling robotics, where a robotic arm can learn to pick up an object by trying different movements and being rewarded when it successfully grabs it. Self-driving cars, where the AI learns to navigate a road by getting rewards for staying in its lane and penalties for swerving. To recap, machine learning is a subset of AI that allows computers to learn from data instead of being explicitly programmed. It finds patterns in data to make predictions or decisions, and it improves on its own over time. The process has two main steps: training and inference. Training is when the model learns a relationship between features, the facts, and labels, the correct answers in your data. The result of this process is a trained model, which you can then use for inference, making predictions on new data. Supervised learning, the most common type, the model learns from a labeled dataset with known answers. Unsupervised learning, the model works with unlabeled data to find hidden patterns and groupings on its own. Reinforcement learning, an agent learns through trial and error, receiving rewards and penalties to achieve a goal. Next, we'll dive deeper into how a machine learning model actually learns and is evaluated.